So this is the 64th video on Newton's laws of motion. So in this video also I'll take up a numerical problem on Newton's laws of motion based on the concept of combined equation of motion and pseudo forces involving translating non-inertial reference frame. Okay, I'll write down the question first. Question is this: two particles of masses m and small m, where it is given that capital M is more than small m, are placed on the two smooth faces of a light wedge. Okay, and the wedge rests on a smooth horizontal surface. Plane. The faces of the wedge are inclined to the horizontal at angles alpha and beta respectively. Okay. The system is released from rest. Okay. Prove that the smaller particle will move up the face on which it is placed if tan beta is less than m sin alpha cos alpha m plus n sin square alpha. This has to be proved. Okay, fine. So first what I'll do, I'll draw the diagram of the situation. Alright. This I'll wrap it. Okay. So first I'll draw the diagram of the situation. Fine. So see, this is the smooth horizontal plane. This is a wedge, light wedge, whose mass has to be taken to be 0. Here a block of mass capital M is placed here. This makes an angle alpha, this incline. And here the particle of mass M is placed This makes an angle beta. Okay. Here they have been told to be particles. I've drawn them as blocks. Okay, so there is no problem regarding that. So now question is that when the system is released from rest, it is required that the particle of smaller mass should rise up the wedge. Okay. So now see, first of all, what is the thing which has to be done? See, first of all, we must know that on releasing the system from rest, in which direction should the wedge accelerate? Suppose I take the fact that wedge accelerates towards left, okay, with respect to ground. See, the wedge is free to move over this smooth horizontal surface, okay. So when the system is released from rest, this wedge will begin to move on the surface. But we must first know in which direction should it begin to move, so that the particle of mass small m begins to climb up this face. Now there are two possibilities after releasing the system from rest. With respect to ground, either the wedge moves towards left or towards right. Now we must first decide whether it should move towards left or towards right, so that this particle begins to rise over this inclined face. If the wedge accelerates towards left, okay, then what will happen? See, suppose the wedge accelerates towards left with acceleration a with respect to ground, okay. This is capital M. This is small m, okay. Now this wedge is a translating non-inertial reference frame. Fine. I draw the free body of this particle as seen from wedge. So what are the forces? One, the real force mg. This inclined face will exert some normal reaction N1. And this wedge is a translating NIRF. As seen from the wedge, a pseudo force will act on this block in opposite direction to A, whose magnitude will be MA. Now see, these are the only three forces acting on small m as seen from wedge. Now you can see that this N1 has no component along this direction. But this force MA has a component along downward incline. This also has a component along downward incline. So under the influence of these two forces, this particle cannot begin to climb up the wedge. So this case is ruled out. Okay. So in order that the particle should climb up the right inclined face of the wedge, so after the system is released from rest, the wedge should accelerate towards right. Only then there is a possibility that this particle will begin to climb up this inclined face of the wedge. Okay. So till now we have decided that in order that this particle of mass small m begins to rise up this wedge should accelerate towards right with respect to ground. Because if it accelerates towards left with respect to ground, then the resultant of on this particle as seen from wedge, there is no force which acts in this direction, which makes an acute angle with this direction. See, these two forces make obtuse angle with this direction. So net force on this block as seen from wedge will be along this direction, not along this direction. Then it cannot climb. Okay, so this case is ruled out. So wedge should accelerate towards right. Only then there is a possibility that this small m will rise up the inclined face. Okay. So now let us assume. So therefore, let us assume that the acceleration of wedge with respect to ground is a rightward. Okay, fine. This solves a bit. Okay. So A is the acceleration of wedge with respect to ground. Wedge has been denoted by W. Okay. This particle of mass small m has denoted by P1 and this particle has been denoted by P2. Okay. Now the question is that with respect to wedge, the particle should begin to climb up the wedge. Okay. So let us assume that this particle of mass small m begins to rise up the inclined face of the wedge. So let B be its acceleration with respect to wedge. Okay. So B is the acceleration of P1 with respect to the wedge. Okay. Now, as seen from wedge, this particle will accelerate down the wedge. Let its acceleration be C. C is the acceleration of P2 with respect to wedge. Okay. Now, what should be our starting point? Tell me. What should be our starting point to solve the given question? Starting point should be this. It is required that this particle begins to rise up the wedge incline. So we have assumed that this particle is beginning to rising up this wedge incline. So this means that B should be more than 0. Okay. Now what should be our aim be? To find an expression for B and set it to be more than 0. Okay. Now first what I do, I draw the free body of this particle P1 as seen from the wedge. Okay. So I draw the free body of this particle here. One mgx width wedge will exert a normal force N1 on this. Okay, fine. Now we are drawing the free body of this as seen from wedge. Wedge is a translating NIRF. So pseudo force will act on this particle in direction opposite to A. Okay, and its magnitude will be MA. Fine. Now what I do, this is angle beta. Okay. Now apply Newton's second law to block up the incline with respect to the wedge. Fine. I apply Newton's second law to this block up the incline with respect to wedge. So since they are accelerating upward, so this angle also beta by corresponding angles. So what do you write here? MA cos beta minus mg sin beta. N1 has no component in this direction, so it goes away. That is just equal to mb. Okay. Now m goes away, that's common term. So b is equal to a cos beta minus g sin beta. Okay. So this condition I write it here. This is the first equation which I have written. First equation is b is equal to a cos beta minus g sin beta. So b I write it here. A cos beta minus g sin beta is the first equation. Okay. Now it is required that b is to be positive. So this b should be positive. That meaning a cos beta minus g sin beta should be positive. So that meaning a cos beta should be more than g sin beta. That meaning a should be more than g sin beta by cos beta, that is simply tan beta. So this is the C. So b more than 0 is equivalent to a more than g tan beta. Okay. The only thing what we must do is that we must find out the value of a and set it to be more than g tan beta. Then the block will begin to rise up this incline. Okay, fine. So a should be more than g tan beta. Fine. I'll rub this one. Fine. Now what I do, I apply Newton's second law to P2 with respect to wedge down this incline. First I draw the free body of P2 as seen from wedge. Okay. So this is P2. Okay. This is the weight mg. This wedge will exert a normal force N2 on the P2. Okay. And wedge is a translating NIRF. So as seen from wedge, a pseudo force will act on this P2, opposite direction, opposite to A. Its magnitude will be m times A. Okay. Now apply Newton's second law to P2 with respect to wedge down the incline. I apply Newton's second law to P2 with respect to wedge down the incline. N2 will have no component in this direction, only these two forces will have the component. So it will be MA cos alpha plus mg sin alpha is equal to mc. Okay. So m goes away. A cos alpha plus g sin alpha is equal to c. This is the second equation. Fine. So this equation I write it here. A cos alpha plus g sin alpha is equal to c. Okay. This is the second equation. Fine. Now we have already found the condition that for b to be more than 0, it means a more than g tan beta. Now you must determine the value of a and set it to be more than g tan beta. And this will mean that this small m will climb up the wedge incline. Okay. Now to find this a, what we must do, we must write down the combined equation of motion of P1, P2 and W in rightward direction. Okay. Now regarding combined equation, one thing should be noted, that in combined equation only real external forces appear, no pseudo forces come. So first thing, to draw the free body, apply combined equation to this entire system in this direction. We draw the separate free bodies of P1, P2 and wedge as seen from ground. Okay. Only real forces will appear. Fine. So I draw the free bodies of P1, P2 and wedge separately as seen from ground. So I draw the free body of P2 here. Okay. this is Ng, okay, this is N2, okay. No pseudo force will act on it because we are writing down the combined equation in ground frame, which I have already specified in numerous examples in previous videos also. I draw the free body of this M, small m, with respect to ground, okay, Ng and N1, okay. I draw the free body of this wedge, okay. This angle is alpha, this angle is beta, okay. Light wedge, wedge is light, so weight will be 0. The blocks will exert normal contact forces respectively. Small m will exert N1, this will exert N2 in accordance with third law. And here a normal reaction N3 will act as seen from ground. Okay, fine. There is no other force. Now we have to write down the combined equation of these three systems with respect to ground in this direction. We know that only real external forces appear. First of all, we must note down what are the internal forces of the system. This N2 and N2, they are internal forces between P2 and wedge. This N1 and N1, they are internal forces between P1 and wedge. They are all internal forces. Only external forces are this and this. Okay. Now the component of these external forces in this direction all are 0. Fine. So I write 0 here. Net external force on the system P1 plus P2 plus W in rightward direction. Net real external force, that is 0. Fine. That is equal to summation of mass times acceleration over particles of wedge. But wedge has a 0 light wedge, 0 mass. 0 into A. Fine. Now what I must do? Now apply it and find this term. First I write down the name of the term. N times acceleration of P1 with respect to ground in this direction. Let us call this direction as say x direction, along which unit vector is I hat. Okay, what do I write here? M times x component of acceleration of P1 with respect to ground, A P1 gx. What does that mean? X component of acceleration of P1 with respect to ground, A P1 gx, plus capital M x component of acceleration of P2 with respect to ground. So that becomes what? A P2 gx. Alright. Now this term goes away, 0 into a 0. Now this I express as a dot product. So A P1 gx will be written as A P1 g dot I hat, where I hat is a unit vector along x axis denoted with this symbol, plus this term A P2 gx, that will also be expressed as a dot product dot I hat. Okay. So 0 is equal to n times. Now A P1g will be written as what? A P1w plus AWg dot I hat, translating frame formula, plus capital M A P2w plus AWg dot I hat, in translating frame formula. Fine, alright. Now rub this, okay. All these equations I have written is summarized here, so this I can rub now. Till here I rub it, okay, fine. So now I simplify this term here. 0 is equal to m times A P1w, it is nothing but vector B, plus AWg, it is nothing but vector A dot I hat, plus capital M times A P2w, it is nothing but vector C, plus AWg, it is nothing but vector I, vector A, okay, fine, dot I hat. Now evaluate this, break this using dot product of vector theory, okay. This becomes 0 times B dot I hat plus A dot I hat, capital M C dot I hat, A dot I hat, okay. 0 is equal to small m. Now what about B dot I hat? B is in this direction, I hat is this direction. Angle becomes 180 minus beta. B dot I hat becomes magnitude of B into magnitude of I hat 1 into cosine of angle between B and I hat, which is simply pi minus beta from this diagram. Cos pi minus beta. And what about A dot I hat? A dot I hat becomes magnitude of A1, A into I hat, magnitude of I hat 1. Angle between A and I hat, that is simply 0 degree, that is simply cos 1, cos 0 degree is simply 1, plus capital M C dot I hat. Now see this way, I hat is that direction, angle becomes pi minus alpha from geometry, internal angle. This I write as c into 1 into cos pi minus alpha, and a dot I hat simply becomes a, as it was in this case here. This becomes a. Okay, fine. Now I simplify this. This becomes minus cos beta, this becomes minus cos alpha. So this becomes minus b cos beta plus a plus m times minus c cos alpha plus a is 0. Okay, fine. Now rub this one. So now solve this for a now, and I substitute b and c in this. Okay, so I take a common. M plus m minus mb cos beta mc cos alpha is 0. Okay, now b and c, I substitute this in this equation. So this becomes m plus m minus m cos beta, and b becomes a cos beta minus g sin beta. So it becomes a cos beta minus g sin beta minus mc cos alpha into c. C becomes this, a cos alpha plus g sin alpha. That's all added up to 0. Alright, fine. Okay, fine. Now what I do, I rub all this. Okay, till here I have written it, the equations. Alright, fine. So cos beta I replace this, b I replace by this, and c I replace by this. Okay, alright, I rub all this. Okay, so now I take a common here also. So when I take a common, what do I get? M plus m minus m cos square beta, and here m cos square alpha minus m cos square alpha. Okay, that is same as, now shift g term that side, this goes that side, so it becomes g common, m sin alpha cos alpha minus m cos beta sin, here it is minus plus, it goes that side again, minus m cos beta sin beta. Okay, fine. So it becomes g times m sin alpha cos alpha minus m cos beta sin beta upon, now here small m is common and capital M is common in this, so I take common, 1 minus cos square alpha small m into 1 minus cos square beta. Okay, g becomes m sin alpha cos alpha minus m cos beta sin beta. This becomes 1 minus cos square alpha becomes sin square alpha, and 1 minus cos square beta becomes sin square beta from trigonometry. So it becomes n sin square alpha plus m sin square what? Beta is the required value of a. Now a should be more than g tan beta, so that b has to be positive, so that particle of mass small m begins to rise up the wedge incline. Fine. So now a should be said to be more than g tan beta. A we already found out. This should be more than g tan beta. Or tan beta can be written as sin beta by cos beta. Okay. Now what I do, I shift this term that side. Fine. All right. So here g will cancel out. You can see here g, this will cancel out. So what do I get? M sin alpha cos alpha m sin beta cos beta is greater than, I shift this side, that multiply this, cross multiplied that, tan beta into m sin square alpha m sin square beta. Okay, fine, all right. Now what I do, I rub all this. Okay, now what do? This sin beta cos beta I bring it this side, and this time I bring it this side. Okay, fine, all right. So what do I get? M sin alpha cos alpha. Okay, I shift this term to this side, becomes greater than, this is right here, greater than, this term I bring it this side. Okay, so it becomes tan beta into m sin square alpha, and plus this term tan beta m sin square beta m tan beta sin square beta plus m sin beta cos beta. All right, fine. So this becomes m sin alpha cos alpha is more than, now in this I take m sin beta common. Okay, m sin square alpha plus this is our right side of inequality, m sin beta common. So this becomes cos beta plus tan beta into sin beta. When m sin beta becomes common, so tan beta into sin beta. Tan beta into sin beta. Okay. So this becomes m sin alpha cos alpha more than alpha tan beta. Now plus m sin beta. Now this I write as cos beta. Tan beta becomes sin beta by cos beta. One sin beta is here already. So this becomes sin square beta by cos beta. Okay, fine, all right. Now what I do, I rub this one. Okay. So what do we get? We get m sin alpha cos alpha is greater than m sin square alpha tan beta Now this cos square beta multiplied plus m sin beta, and cos beta is here already, cos square beta plus sin square beta, cos square beta plus sin square beta. And this becomes 1 from trigonometry formula, and this sin cos becomes tan. M sin alpha cos alpha is more than this becomes 1, and this becomes sin cos becomes tan. M tan beta. Okay, so this means I take tan beta common and write it left side. Tan beta m sin square alpha plus m is less than m sin alpha cos alpha. So tan beta should be less than m sin alpha cos alpha m sin square alpha plus small m. This is what is required to be proved. Okay, as proved. Fine, all right. This is what we are supposed to prove, and has already been proved. Fine. So this was 64th video on Newton's laws. Okay, so this is one of the finest problems. See, such questions can be asked in AJ Advanced linear comprehension type. They give the introduction of the question, and then they break up into 2 or 3 parts, each 4 numbers. Suppose they divide this question into 3 parts, A, B, C, 4 marks each, to 12 marks for this question. This will be a rank deciding question. Whoever solves this type of problems will score 12 marks. His rank will shoot up. So definitely you must solve problems of this type. Then only you will gain the accuracy, confidence and speed to tackle the problems of J Advanced. Okay. So you go through it. If you have any doubt, you write it in the comment box. I'll clarify it. Fine. I close it here.